Howdy Pirates! Today we're going to talk about the mole, and not that furry animal. We're talking about a mathematical value. Okay? So you remember that atoms are extremely small. They're so small that we cannot see them. So we need to be able to work with a large amount of atoms. So just like you don't buy one shoe, you buy a pair of shoes. Just like you don't tend to buy one donut if you're having a gathering or for your family, you tend to buy a dozen or 12 donuts. Okay, and you can start to see these quantities that are commonly used, just like a case. You might not buy one individual soda pop or can. Instead, you're going to buy a case, which is 24 cans. Okay, well, similar to that is a mole. Okay, a mole is 6.02 times 10 to the 23rd atoms, or anything really. It's a large number. Okay, so it's also known as Avogadro's number. It's 602 sextillions. So if you count all of these zeros, or if you understand scientific notation, 6.02 multiplied by 10 23 times. That's what 10 to the 23rd means. Okay, so if we put our decimal here after 6.0, we're going to multiply that 23 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so 6 times 10, but you're going to multiply it by 10 23 times. That's how large the quantity of a mole is. Okay, and the idea is if we were to have the mass that's listed on the periodic table, so for example, nitrogen's mass, 14.01, if we had 14.01 grams of nitrogen, we would need a mole of nitrogen, or 6 times 10 to the 23rd atoms of nitrogen. Okay, so let's just talk about how large this quantity really is. Okay, so I just had some common examples here that you can start to realize how large this quantity is. If we had a mole of donuts, so if we had 6 times 10 to the 23rd donuts, they would cover the entire Earth's surface in a donut layer 5 miles deep. That's crazy. If we had a mole of basketballs, or 6 times 10 to the 23rd number of basketballs, we could create a whole new planet the size of our planet Earth. Amazing. If you had 1 mole of rice grains, it could cover the Earth to a depth of 75 meters. So I thought you might be able to visualize 75 meter sticks above us. Okay, we would be drowning in rice. And if we had a mole of hockey pucks, it would equal the mass of the moon. Okay, so this is a very large quantity. So our goal today is to go over how you're going to use this quantity in some of your calculations and how to use the calculator on your iPad. Okay, so these two equalities are just an example of what you can use for a mole. I mean, let's be honest. If I said I had a mole of donuts, so a dozen donuts would be 12 donuts, right? If I had 1 mole of donuts, I would have 6 times 10 to the 23rd donuts. Okay, you notice I did drop off the 0.02. Some people just round it to 6, and that is fine with us. Okay, so we could say a mole is 6 times 10 to the 23rd of anything. So a mole of atoms would be 6 times 10 to the 23rd atoms. A mole of molecules would be 6 times 10 to the 23rd molecules. Okay, so let's look at some sample calculations here. Okay, and you already know how to use your conversion steps. Remember, you want to use your equalities to cancel out given units and solve for what you're looking for. Okay, so in this problem number 1, it says how many marshmallows are there in 5 moles of marshmallows? Okay, so you have to think of what we're starting with here. What's our given? Okay, and our given is 5 moles of marshmallows. Okay, and we want to know the quantity, how many marshmallows there are. Okay, so if you think of this equality up here, we know that 1 mole is equal to 6.02 times 10 to the 23rd of anything. Donuts, marshmallows, erasers, rice grains, hockey pucks, anything. Okay, so if this is the equality we want to use, 1 mole equals 6.02 times 10 to the 23rd, in this case, marshmallows, we have to figure out how we want to set up that equality. So we know in our next step, we want marshmallows to cancel. So we notice we are starting with moles at the beginning. So we want moles to cancel, so our moles are going to be underneath. And in 1 mole, there are 6 times 10 to the 23rd marshmallows. And notice I did drop off the 0.02. So if we have moles divided by moles, our mole unit will cancel and we will be left with marshmallows, which is what we are being asked to solve for. So mathematically here, you're going to multiply everything in the numerator and then divide by everything in the denominator, which in this case is 1. So in the numerator, we're going to take 5 moles times this quantity, 6 times 10 to the 23rd, which I'm going to show you in a calculator here. And then the only number in the denominator is that 1. Okay, and to make this easier to know the difference, I'm going to put a dot here for multiplication. So on your iPad calculator, if you have a basic calculator or scientific, you should already know how to use your exponent values. But if you're using the iPad free calculator, at the bottom here, you'll see on the basic mode. If you switch over to scientific, you'll see here you do have 10 to the power. However, I like using the third button from the left on the bottom, this double E button. Okay, so if I'm using a mole, 6 times 10 to the 23rd, I type in 6, double E. That tells my calculator times 10 to the power of 23. Okay, and if I hit equals, it just says the same number there. You just have to know how to read the output that it's going to give you. So if we look at our problem here, we're looking at 5 times 6 times 10 to the 23rd. So I'm going to type in 5, multiplication, 6, double E, 23. And then when I hit equals, you'll see the number they give me is 3E24. 3E24. So write that down here so you can see it. Okay, you have to remember what that translates. That means 3 times 10 to the 24th power of marshmallows. Wow, I think that'd be enough marshmallows for our entire society to make enough s'mores with forever. Okay. All right, let's try the next sample problem. The next one says, how many atoms of copper are found in 3 moles? 3 moles. So the first thing, of course, is to know what you're starting with. In this case, it's 3 moles of copper. So no matter what we decide to do in our next step, we know moles are going to have to go in the denominator here to cancel, right? All right, we're trying to solve for atoms. So if you notice up here, we do have an equality that we can use. 1 mole is equal to 6.02 times 10 to the 23rd atoms. So the 1 mole is going to go on the bottom, and 6 times 10 to the 23rd atoms of copper will go on the top. So then in our calculator, we're going to take 3 times 6 times 10 to the 23rd, and we get 1.8 times 10 to the 24th. And you notice there's no numbers besides 1 in the denominator that we have to divide by. So that is our final answer. Okay, let's try one more sample problem so you get an idea of how to use some of these equalities. How many moles of water are in 5 times 10 to the 24th molecules of water? So we're starting with 5 times 10 to the 24th molecules of water. And we're trying to solve for moles of water over here. So think of what equality we need. We need something that's going to start with molecules and directly get us to moles. So we look up here, we have an equality, and it's up on the wall in your classroom as well and on your mole map. 1 mole equals 6 times 10 to the 23rd molecules. So the main thing to keep in mind here is the fact that since we're starting with molecules, in our next step, the unit molecules has to go down in the denominator to cancel with the molecules in the numerator. So this is probably one of the most common problems, is knowing whether or not to put 1 mole over 6 times 10 to the 23rd molecules or 6 times 10 to the 23rd molecules over 1 mole. Okay, keep 2 things in mind. You want the units to cancel. And the second thing is to keep these equalities in mind. Okay, 1 mole is equal to 6 times 10 to the 23rd molecules. So in front of molecules, 6 times 10 to the 23rd molecules equals 1 mole. Remember, these are equalities that you're using as like a conversion step. So this is the first time in our calculator we actually have a division problem. Because in the numerator, we have 5 times 10 to the 24th times 1, which is 5 times 10 to the 24th, divided by the denominator, which is 6 times 10 to the 23rd. So let's try that in our calculator. 5 double E 24 divided by 6 double E 23. And we get 8.33 moles of water. That's it. I hope you have a great day. Go Pirates.